Hi, this is Sonia Doucette. In this problem, I'm going to show you how to find the wavelength of matter. So the problem says if a proton, and you're given the mass of the proton, is accelerated to 25% of the speed of light, what is its wavelength in meters? The relationship we can use here is that the wavelength of matter is equal to Planck's constant divided by the mass of that matter, which we're given here for this proton, multiplied by the velocity. So note that this v term is velocity and not frequency, which is the Greek letter nu. They're two different things. So we're also told that it's accelerated to 25% of the speed of light. So based on that information, we can find the velocity. So you change that percentage to a fraction, so 0.25 multiplied by the speed of light, which is 2.998 times 10 to the 8th meters per second. And for the velocity of this particle, you get 7.495 times 10 to the 7th meters per second. So there's our v term. We have our mass and Planck's constant is known. So let's start plugging in some terms. Here's Planck's constant, 6.626 times 10 to the negative 34 joule seconds divided by the mass, which is 1.673 times 10 to the negative 24 grams, and we'll multiply that by our velocity, which is 7.495 times 10 to the 7th meters per second. So doing a unit check here, you'll notice that the units don't make sense, so we have to do one conversion to make things work out. So let's just look at this first. We have joule seconds per gram, and we flip this unit around because it's in the denominator, and what we'll end up with there is joule second squared per gram meter. So this is not a unit for wavelength, so we need to do something here. The relationship we can use is that in 1 joule you have 1 kilogram meters squared per second squared. So what you can do is plug this in for the joule and make sure that the units work out. So if we do that, we're going to get kilogram meter squared second squared, and in the denominator we have second squared gram meter. So let's see what happens here. Second squared cancel, one of the meters cancels, so we're left with kilogram meters per gram. So we can get to units of just meters, which is a unit that makes sense for wavelength, if we convert the mass of the proton to kilograms. Then those units of mass can cancel. So let's do that as part of our equation. So what we're going to do is we're going to say 1.673 times 10 to the negative 24 grams, and we're going to multiply that by the conversion factor that says there are 1,000 grams in 1 kilogram. So now you can see, and we're also going to plug in the conversion from joules to kilogram meter squared per second here, and what we'll be left with when we do that is kilogram meters squared per second. And we're going to get rid of this term because we're changing that to kilograms, and get rid of these units. We have these new units here. So now let's look and make sure everything cancels as it should. So grams will cancel, kilograms will cancel, seconds will cancel, and we'll be left with just meters for the units. So now that we know the units are going to work out, we can do all the math, and when you do that you should get 5.284 times 10 to the negative 15th meters. So that would be the wavelength of this proton given its speed.